Christophe Priuso from ST Microelectronics, and I'm actually an Linaro assignee on a Linaro home group. I'm here to present you a little statue or one of my tasks on LMG group, which are to help to introduce a video decode on Chromium. And on this presentation, you must see a little status and all the things we have seen which are bad or correct. Okay. The main goal, which are to provide a video decode hardware accelerated in the case of the security implementation. It was to propose to make a video decode just after to have a DRM decryption of the buffer, and to and just to be able to make the video decode also on security. For that, we have decided to use the V4L2 interfaces because on the ST board we have these interfaces, and on Qualcomm board we have also these interfaces. For that, we are using the two boards, the STH410 B2120 from ST Microelectronics and the Dragon board from Qualcomm, the 96 board. When we make this task, we are encountering some issue, mainly with the GPU configuration, mainly on user land, because we doesn't use the same library. For B2120, we are using the delivery for ARM Mali 400, and during this task, we are using two versions. The first one, the R4P1, which contains the basic delivery from ARM, and also the ST implementation for Wayland, because we are using an environment based mainly on Wayland Weston plus Chromium. The second one we are used at the end is the R6P0, because Wayland are natively implemented on the ARM delivery, and also the extension ImageDMA import are also available, which is not a part of the previous version R4P1. For Dragon board, it's another way to use the GPU. We are using the Mesa version, which also has the ImageDMA import interface, and also Wayland implementation. During my task, I have seen that we have an issue with Mesa implementation, because the video for Linux video decode propose only to have a YUV output format, but the interface image buffer import on Mesa implementation for Qualcomm board only use RGB BGR format family. It's a little restriction, but it doesn't match with the task we like to implement on Chromium. It's why you make only the work on B2120 ST board. One of the big challenges was to use Chromium. For me, Chromium is an OS under another OS. We have a lot of parts on Chromium, and is mainly dedicated at the beginning to be used on desktop environment, not of embedded environment. It's a big challenge because each embedded environment has different configuration, different hardware, and different way to use the hardware. And we can see that we have two levels of configuration available for Chromium, one for the OS, Android, Chrome OS, Linux, and Mac OS X. And the second one is mainly for the display backend, DRM, EGL, Wayland, X11. And depending of the both configuration, you have access to some functionality or not. It's the case for Video for Linux. Video for Linux are available only for Chrome OS with a DRM or EGL or Wayland, not for X11. Another challenge with the build and the size of the binary size, because Chromium is a huge project, is a lot of code, and on my PC, which are only a Core i5, we take around 6 hours of compilation and around 3 hours of link only for the binary. Is awful. And at least we have a binary with debug information on it, which are around 3.2 gigabytes, and it's awful if on the product you have only a little SD card or little eMMC. And we need to strip it always to push it directly on the board. It's an issue because it's difficult to use it with a GDB, but we have a lot of traces available on Chromium to make the debug. One another challenge is on PC, we are using mainly the RGB family for output format, and on embedded world, we are mainly using YUV data. It's not the same way to use the data. Yes. On Chromium, you have different way to make a video playback. One are to use some plugin API like Paper API or Mojo API. Another way to use the native implementation of video playback like HTML video tag, which are using the web media player interface, which on this interface we are using video decoder, video renderer on the pipeline, and we have two kinds of video decoder available. One part are only on software, mainly based on FFmpeg and libvpx, and other one are mainly based on GPU usage. When you say GPU usage, is only for the rendering part, not for the decode. The decode are not made by GPU, but by specific IP on other hardware. VT, Video Toolbox for Mac OS X, VA API for Intel platform, Video for Linux for Chrome OS platform. Ozone is mainly if you are using other plugin on your backend, display backend, and Android video decoder. The main difference between the software video decoder and GPU video decoder is where we are executed. The software video decoder are executed on the renderer thread, and the other one are used mainly on GPU thread. It's the main difference because to pass between renderer thread to GPU thread, you need to have a conversion of color, because at least we have always made a GPU rendering. And we need to make conversion between when you pass one thread to another thread. Actually, a little status of the video format available for each video decoder. FFmpeg are using mainly YUV format, but at least we have some transformation with GPU scale, shader to transform at least on RGBA format. VPX always use a YUV format. Video for Linux are using NV12, interlaced 420, and ARGB. But it's really depending on your configuration on Chromium, because NVDOs normally are only available for Chrome OS and Mac OS, not for Linux or Android or other configuration. The last one, via API, the Intel platform are using RGBA. Yes, on the GPU, the video decoder for the rendering are allocating some EGL image by different way, and it's mainly to make a kind of tunneling via the GPU interfaces. And we are strange, each video decoder use different way depending on the configuration. It's really a nightmare to have a common interfaces for each hardware. Video for Linux have two implementations actually, a default one provided by Chromium and the Google guys, which are using the EGL create image share function, but by passing argument DMABUF extension. And with this way, we can pass any YUV format. The second implementation, which are mainly made for Tegra hardware, we are using the texture 2D share interfaces. For via API, we have two ways to use it. One by X11, we just attach the buffer to the texture 2D. For Ozone, it's the same. We attach the buffer to a texture external OES. For Android, we also attach to the texture the buffer, and here by texture external EOS. It's a different way to pass the buffer to the Chromium compositor to make the rendering at least. And it's really depending on the configuration. And we have seen a lot of issue because it's also depending of you GPU userland library implementation. It's the last slide. Here it's a status of what we have seen. I have implemented two kinds of video decoder, one in software, which are working correctly for the video decode, and for the rendering, we provide NV12 buffer, but we have no chance because NV12 are not supported by this way, like a YUV format, and we need to make a cast to interlaced 420. We have a rendering, but with some artifact because it doesn't provide the good order of YUV on the YUV format. We also provide another implementation based on GPU video decode. We are just changing the configuration because we are using a Linux interfaces. And by this way, I'm not lucky because the video decoder works correctly, but at least when we pass the buffer to the EGL interface, I don't know why, there are no issue, but we are no rendering. I think it's probably due to some call of Chromium interfaces to EGL interface, which crash my buffer. I don't know why. but at least it's the static I have. We have made this presentation mainly to make a status of this task and to have your feedback how we can converge and have a solution, to have a solution which can work on several boards, because actually it's working only on being 2120, but it's ST board and with a restricted access, and Linaro we can access mainly for 96 board, like Qualcomm or IT board, but IT board actually doesn't provide video for Linux interfaces. And we would like to promote this interface in Linaro, because we know with Android we would like to converge to these interfaces for the next version of Android, and for Linux way we would like to use it also. And we have an issue actually with 96 board to make it. Any comment?
So I guess the main problem is that if we look Chromium, how it's used as a part of a Chrome project or Chrome OS, the main focus on the Linux build, are the desktop builds. And on the desktop builds, they have enough, processing power just to use the multi-threaded FFmpeg. So there are no high priorities to solve this issue, specifically because they would need to deal with the variety of various hardware on the PC side. And when we look for embedded, the main focus of the Chromium project is the Chrome OS project, or Android. And as such, it leaves a kind of hole for people who are using the Chromium project as an embedded Linux project. And this is what we see, that features are simply delayed or not implemented. We see the same thing like with GCC support for the Linux builds. It's working properly for x86 builds because that's a priority, but the GCC issues for Linux embedded are getting fixed as the last problems. With GCC for Android, there are no issues. So I really think that Chromium is a community project, and for people interested in using Chromium on Linux, we need to fix it in some way and get that upstreamed.
Hi, I'm Rob Clark. I mean, I would say most of my comments are on the GPU driver side and maybe to some extent on the API side, not so much on the build or so on. I mean, I know I've tried to build Chromium browser for ARM Linux X11 before and gave up because the build system had too much assumption about X11 equals X86. So yeah, I know that's a pain, but I don't have anything constructive to add there. I can comment a little bit on what the issues are with the Mesa and EGL image and YUV. There's kind of two issues there, and from the desktop side, they have VA API, which takes a different approach for rendering, which kind of actually solves the same problem, but in an inverted way. So a little bit of background. A little bit of background. There's kind of, actually, I'd mentioned one problem to you the other day. There's actually another problem, another challenge, let's say. One is Mesa State Tracker doesn't really differentiate between renderable and sampleable formats. So, I mean, the assumption is if you have a surface, it's something you could render to, which is not true for YUV and especially and multiplanar. The other thing is for implementing EGL image external for YUV textures, surfaces. On most GPUs, you end up kind of having to do a hack because behind the scene, the driver is actually using 2 samplers and inserting instructions in the shader to do the color conversion. There is some hardware that can directly sample YUV, but I think that's not as common. When you take 2 samplers, then you're actually lying about the number of textures you advertise in GL. So if you say the hardware supports 16 textures, and then you try and use 16 EGL image YUV textures, that's not going to work because you need 2 samplers for each. The way this is solved on the desktop side with the VA API is you don't ever see the, I mean, it is YUV under the hood, but you never see the YUV. VA API and VDPAU is similar, has a, I don't remember the correct name, but it's got a renderer component that takes a surface and combines it with other GL surfaces on top. So under the scenes, like most of the desktop drivers implement both the video decode and the GPU in a single Gallium driver. So Gallium has interfaces for video as well. Behind the scenes, that's taking the YUV in whatever format, which might even be some like crazy custom tiled YUV format, and generating the shaders using multiple samplers to combine that with whatever GL overlays, you know, like on-screen display or whatever you might have. So, and then that gets rendered directly to the, like if it's X11, the PIX map. So it's really the same number of data copies. It's not introducing an extra copy, but it's kind of inverts how you do it. You never really see the YUV as a texture. And yeah, I mean, since that fits for most of the discrete GPUs, I don't think anyone on the desktop side has too much motivation to try and deal with that. It might be, I mean, if you can pass around 2 EGL images and call them, you know, lie about the format, say it's GL red and GL red green, say, and then have the shader do the color conversion explicitly, that problem kind of goes away. I was actually just talking to Stan a moment ago, and I'm not even sure if we can get 2 separate images out of the Qualcomm decoder, so that might be, you might be able to do this similar sort of thing, playing games with texture coordinates or something, sampling the same texture twice. Or maybe there might be another way. I don't know if they're available in GLS. There are some extensions, I think, that give you a separate sampler view, so you can have multiple views with different formats on the same underlying buffer. You might need something like that to differentiate between the Y plane where you're sampling a single component and the UV plane where you're sampling 2 components. I'd have to think about that a little bit more. From the driver point of view, it'd be much, much easier if I could ignore the problem and solve it in the application instead. I don't know how practical that is with Chromium in general. Yeah, I think that's.
So do you think this is something we need to solve, you know, on the Mesa side, or there is a proposal that we can came up and, you know, propose to the Chromium community to improve the way how Chromium is handling V4L?
If you could get separate buffers per plane, so like for NV12 to DMA buffs, and you could convince the Chromium folks to support that mode, that would be easier. I mean, that sort of approach I think would be fairly simple, like with, for example, GL image sync, but that's a much smaller piece of software, and there's, you know, so that sort of change would be much easier to deal with. I don't know on the Chromium side. Yeah, I mean, I guess, you know, well, at least with Mesa we have the source code. So I mean, if someone, you know, I don't think, if done properly, I don't think necessarily the changes would be rejected. I
believe the Chromium community is a very open community, so they really try to manage it as an open source project. So I also see a potential that we would create a proposal how to fix this, how to support this in Chromium.
Yeah, I would say you would maximize the number of drivers that would be supported if you could do the color conversion explicitly in the shader, because that would work with every driver. So yeah. I mean, logistically, I don't know, like, for example, is it easy to pass 2 buffer handles instead of 1 between the, well, actually, you said the hardware decode is in the GPU process already, so you don't need to pass the DMA buff handles across process? Or, I'm a bit fuzzy on those sort of details.
Yeah, you actually do need to pass the DMA buff process.
Actually, we are using the DMA buff to pass the 2 plane
Okay.
of NV12.
Okay, but I mean, are you already passing that as 2 DMA buffs, or? I guess you must be, because the ARM EGL image extension is probably taking 2 DMA buff handles.
Yes, we are using 2 DMA buff.
Okay, so then that means the issue is at least self-contained into the GPU process, which is not as bad as I feared, at least.
I'm not really sure. Just by using another use case, just by making a video playback with JetStreamer, we are generating NV12 with 2 plane, with 2 DMA buff. And we are asking to Weston to make the rendering. We are using the same interfaces. We are passing the 2 DMA buff, and it's working correctly. But in this case, between the JStreamer and the compositor, there are not other call to the EGL interface. It's the main difference. Chromium make a lot of stuff to work on the EGL buffer between the end of the video playback for the rendering and when we compose it to send it to the display. Is the main difference between the 2 use cases.
Okay.
But with Weston, it's working correctly.
Okay. Yeah, I mean, I guess it doesn't surprise me if Weston already supports doing the color convert in the shaders. I mean, that should be pretty simple to do in Weston because it's a much smaller body of code. So, yeah. Yeah, I mean, the big wild card is I'm not even sure if we can rely on getting 2 DMA buff handles for all different decoders. So.
You always pass a DMA buff handle and an offset side, right? So in the worst case, you would use the same handle.
Correct. Actually, you're right. Yeah. You're right. You could actually just do the create EGL image twice with separate offsets. Yeah. Okay. Yeah, that's not so bad. Okay. Yeah. Then I guess it's just a matter of picking the right shader variant. I don't know if, I mean, is Chromium doing a lot of other stuff in the same shader that it uses to stick, I mean, I guess it must have to deal with other layers that appear on top of the video, and things like that.
Yeah, usually, you know, you have the graphics overlay on the top of video.
Does that, I mean, is it doing that in 2 passes where it flattens however many layers on top, or is it, or could you have like 5 different surfaces that get composited over the?
Actually, it can have multiple surfaces, so what it does, it tries intelligently collapse the DOM tree into different layers and do the actual composition of those various layers using the Chromium compositor.
Okay.
So there is a quite complex internal logic how this composition is happening inside the Chromium compositor.
So does it just dynamically generate a shader with different number of samplers based on?
Yep.
Okay. So I guess whatever fragment it inserts for each layer would have to have a different version for YUV, which does 2 texture samples instead of 1, and then a matrix multiply. Yeah, I don't know. I mean, if that was doable, it would make my life much easier. I'll say that much. I mean, if that's not possible, I guess we can figure out some way to do it in Mesa. But yeah.
Is there anyone else working in this area with a comment or any feedback on their experience?
Thank you for coming.
So, yeah, one thing I would say for debugging GL stuff, like the thing you mentioned with just getting black rendering, I think Chromium, they should have some tutorial or examples on how to run it with API trace. And the first thing, like from a graphics driver developer point of view, if someone's having a rendering issue, the first thing I want to see is an API trace, because that gives me a good way to reproduce the issue. And it also has a lot of nice features. It'll show if you get GL errors or...
Yes, it was an interface to generate a lot of trace for GPU. I have tried it. I have seen no error.
Okay.
One another issue is I'm not really an expert on GPU. I'm able to use the interfaces, but not really to understand all the workload on the GPU.
Okay. Well, at least on anything with the Snapdragon for Adreno, you can send me an API trace, and I can have a look at it. That's going to be a lot easier than me reproducing your setup. So.
Okay, thanks.
Thank you.